Hi everyone. So today we're talking about something called complex numbers. And complex numbers are really related to imaginary numbers that we used yesterday. Complex numbers are really just a combination of imaginary numbers and real numbers, which are the numbers we work with every day. So complex numbers are made up of two parts. Okay, they are a real number and then an imaginary number. Remember, imaginary numbers are the numbers that have I attached to them. So when I say a complex number, it's not a number like what you're used to thinking of, like 12 or -4. Okay, a complex number is something plus something I. So an example of an imaginary number would be this down here, 2 plus 3i. That's what we call a complex number, where the real part is the 2. Okay, that's the real part. And then the 3i is the imaginary part. So the a is like 2. The a is 2 and the b is 3, and then you've got the I attached on the end of it. That's what we call a complex number. So these are the numbers that you've worked with forever, and then these are the imaginary numbers that we worked with yesterday. So just a little note for you, when you work with complex numbers, the I is going to work almost like a variable. Okay, so you can do the same things with I that you can do with an X in a regular algebra problem. The only difference that comes in is when we hit I squared. And remember from yesterday, I squared can be simplified to -1. So when you see that pop up, you can simplify it a little further. So let's say, for example, I said to simplify 7 plus 3i plus 6 plus 2i. Now I've got these in parentheses just to show you, like, here's one complex number and here's another complex number. But I'm not distributing anything, so there's really no reason to have those parentheses there, so you can kind of ditch them. You can just think of this as 7 plus 3i plus 6 plus 2i. And then combine like terms like you usually would. So 7 and 6 combine to make 13, and 3i and 2i combine to make 5i. Okay, so your final answer would just be 13 plus 5i. So you want your final answer to always be written in this a plus bi form, something plus something I. If your answer doesn't look like this, then you haven't simplified it far enough. Okay, this one. This is a distributive property problem because I've got the 3i on the outside and then the two things on the inside. So I'm going to take that 3i and distribute it. So 3i times 5 makes 15i plus 3i times 6i. Well, 3 times 6 is 18, and I times I is I squared. So remember, anytime you're multiplying an I by an I, you're going to get an I squared. But then also remember that that I squared is really equal to -1. So really this whole thing, the 18i squared, is really a -18. So if I were going to write my answer in a plus bi form, remember the first number should be the one that doesn't have an I. It should be the non-imaginary number. So I'm going to actually start with that -18 and then say plus 15i. So you always want to write your answers with the one with no I first and then the I one last. Okay, so even if the negative, or even if the number comes out over here, you want to put it in front. Okay, now this one I want to point out is very different from example 1. Okay, example 1 a second ago we had, it looked really similar. It was like a parenthesis like this, but it had a plus sign in between, and then a parenthesis like this. This one is just two parentheses next to each other, which means we're going to be multiplying, which means we do need to use FOIL. Okay, so pay attention to whether that's multiplication or addition. You can use FOIL or you can do the box method like we did before. I know, well, maybe I'll show it both ways. So first of all, if I was going to do FOIL, like traditional FOIL, I would do 4 times 2 is 8. 4 times 5i is 20i. 3i times 2, sorry, that's a -3i. Don't miss that negative there. I almost did. -3i times 2 is -6i. and negative 3i times 5i. Well, negative 3 times 5 is negative 15. And then don't forget that you have an I times an I, which makes an I squared. Okay. Where you have that I squared, right now that says negative 15I squared. Remember, I squared is really a negative 1. So this right now says negative 15 times negative 1, which is really just positive 15. So that minus 15I squared becomes just a plus 15. And then you can combine the 8 and the 15. So 8 and 15 make 23. And then 20i minus 6i makes 14i. And again, notice in your answer, you've got that a plus bi form, the something plus something I. Okay? So that's what it would look like with FOIL. If you were to do this with the box method, let me just do that real quick here. If you're a fan of the box method, if not, you can go ahead and fast forward to the next slide. I would do this as 4 minus 3i and 2 plus 5i. Okay, so 2 times 4 is 8. 2 times negative 3i is negative 6i. 5i times 4 is 20i. And 5i times negative 3i, negative 15i squared. Then I want to look at that and say, okay, that one has an I squared on it, so negative 15I squared, remember, is really a positive 15. Okay? So when you go to write your final answer, I can combine the 8 and the 15, which is 23, and I can combine the negative 6i and 20i, which makes 14i. So again, your answer stays the same, just the box method lays it out a little differently. Okay, let's talk about something called the complex conjugate. All right, and this is not going to make a whole lot of sense at first. Hopefully, when you see the examples, you'll see what I mean by this. But so say a complex number looks like this: a plus bi, something plus something I. The complex conjugate looks exactly the same, except it has a minus here. Okay? Or vice versa. If the number started out looking like this, the conjugate would look like this. So conjugate really just means flip that sign in the middle. Okay? Let's practice with that. If I had 7 plus 4i, for example, the conjugate would be 7 minus 4i. 13 minus 6i, the conjugate would be 13 plus 6i. So notice the sign in front is not changing. These numbers are not changing. It's only the sign in the middle of the terms. This one would become 242 minus 74i. So what's the point of that? Why is that helpful? Well, that's what the answer to this question is. What happens when you multiply a complex number by its complex conjugate? Let's take, for example, this first set. 7 plus 4i times 7 minus 4i. Okay, if I FOIL that out, and yes, you could use the box if you wanted to, but I'm just going to FOIL. We'll make my point either way. 7 times 7 is 49. 7 times negative 4i is negative 28i. 4i times 7 is positive 28i. And 4i times negative 4i, well, 4 times negative 4 is negative 16, and I times I is I squared. Okay, so first of all, negative 16I squared can really be turned into a plus 16. Okay, again, because I squared is really negative 1, so negative 16 times negative 1 is positive 16. So I know I'm going to be able to combine that 16 with that 49. But look at what happens with your i's. You've got a negative 28i and a positive 28i. What's going to happen when you add those together? Hopefully you see that those are going to cancel out. And so really all you're left with is 49 plus 16, which is 65. So your final answer on this one is just 65. Now, what's the advantage to that? Well, the advantage to that is you came down to just a single whole number, a real number, okay? The multiplying by a conjugate, multiplying by a complex conjugate, gets rid of the imaginary part of the complex number. So if you're ever in a situation where you have an imaginary number and you need a real number, you can multiply by the complex conjugate, and that will turn it back into a real number, okay? So the answer to this first question, why do we need the complex conjugate? That's what we were just talking about. And you don't have to write this down word for word, feel the phrase. So notice it says denominator because this is going to become important in fractions, and I'll show you why in just a minute. So if you've got a fraction with complex numbers and you multiply it by the complex conjugate, you end up with a real number. That was that 65 that we came out to in just a minute ago. Remember a second ago I said if you're ever in a situation where you need it to not be imaginary, okay? Fractions are a situation where you need it to not be imaginary, and I'll show you why in just a second. In fact, that's the answer to the next question. Why do we have to make it a real number? Why is it not okay for a fraction to have imaginary numbers? Well, I is equal to a square root. Remember, I is equal to the square root of -1. And there's this big rule with fractions. I'm honestly not sure why this rule exists, but it's a rule that mathematicians follow, that you can't have radicals mean like square roots, in the denominator or the bottom of a fraction. So if you've got a fraction set up and there's an I on the bottom, you can't leave your answer like that. You have to get rid of the I on the bottom. And the way we get rid of the I on the bottom is with this complex conjugate. So for example, take a look at this one. This is a fraction, and notice that there's an I in the denominator. That's the problem right there. Okay? Now, you do have to follow your rules of algebra, and your rules of algebra say I can't just get rid of these i's. I know you want to, but you can't just cancel those out because this I is attached to this 2, and this I is attached to the 3 and the 5. Okay? So I can't just do that. That would be nice, but not allowed. So what I'm going to do is I'm going to multiply by something that would get rid of that I. And remember, the one we really care about is the one on the bottom. I don't care so much if there's an I on the top, but the one on the bottom is the one that can't stay there. So I'm going to look at this, and I'm going to say, what could I multiply by that would get rid of the I? Well, that would be the complex conjugate. So conjugate of 3 plus 5i is 3 minus 5i. Okay? And remember, the rule with fractions is you can multiply by anything you want as long as you multiply by the same thing on the top and the bottom. So I'm also going to multiply by 3 minus 5i on the top. So notice I'm not multiplying by the conjugate of the top. I'm multiplying by the conjugate of the bottom and then that exact same thing on the top. Okay? Because you have to multiply by the same thing top and bottom. This is the one I really care about. Okay? So I'm going to use FOIL here just because that's how it'll fit on my screen the best. You could do all of this with the box method too if you wanted to. But I'm going to kind of have to do double FOIL here. So I'm going to have to FOIL these on the top and FOIL these on the bottom. Let's start with the top. I would do 2 times 3 is 6. 2 times negative 5i is negative 10i. This is a negative I times 3, so that's going to make a negative 3i. And a negative I times negative 5i. Well, negative 1 times negative 5 makes positive 5, and I times I makes I squared. Okay, so that's the top FOIL. Now we can simplify it. We'll do that in just a second. Let's go ahead and do the bottom, and then we'll do all our simplifying in one step. The bottom you do have to multiply out. You can't just say, oh, it all cancels out, because it doesn't all cancel out, okay? The I part cancels out, but you'll see that as you work through FOIL. So you do have to go ahead and work through the whole FOIL process. So down here, 3 times 3 is 9. 3 times negative 5i is negative 15i. 5i times 3 is positive 15i. And 5i times negative 5i, well, 5 times negative 5 is negative 25. And I times I is I squared. Okay, plus 5i squared, that's really like a negative 5, okay, because I squared is really negative 1. Negative 25i squared is really like a plus 25, because negative 25 times negative 1 makes positive 25. I also see down here on the bottom that my negative 15i and positive 15i cancel, okay? That's supposed to happen. That needs to happen every single time. That was the whole reason we did this whole process. If this does not happen when you do your multiplication, then you did something wrong. Okay, either you started with the wrong thing or you did some multiplication wrong somewhere. Okay, so up on the top I have a 6 minus 5, which is a 1. Negative 10 minus 3 is negative 13i. And down on the bottom I have a 9 plus 25, which is 34. Okay? Now, technically I'm done, but there is one more thing we should check for. When you write your answer like this, you may have some things that you can reduce sort of hiding. So when you get to this point, then what I would do is write it as two separate fractions. So I would say 1 over 34 minus 13i over 34. And a lot of times you'll see it written like this, 13 over 34 with I down on the side, okay, instead of up with the 13. If you put it up with the 13, I would not mark it wrong. Now, in this problem in particular, it doesn't really matter whether you leave it like this or whether you separate it. But I'm showing you to separate because if you end up with a fraction that you can simplify, like, for example, had this come out to be 17 over 34. Well, 17 over 34 reduces to 1/2. So you would reduce this fraction to 1/2. That's why it's important to look at it as two separate fractions, because one fraction might reduce and the other one doesn't. So after you've got it all as one big fraction, pull it out as two separate fractions, and that is your final answer. Okay? So now that you're done watching the video, if you are in my blended class, you will want to go back into Blackboard and make sure you complete the check for understanding, which is just a couple of questions, couple of examples that are really similar to these notes. Make sure you're looking back at these notes as you're answering the questions. You do get 2 attempts, so if you try it once and it doesn't go well, maybe rewatch the video, reread your notes, go look at some of the extra resources I posted, and try again. Okay? And we will go over this lesson in class on Wednesday.